Shalom to you. In this video, we're going to look at arithmetic and geometric sequences. We're going to write the general terms of arithmetic and geometric sequences and use them to find any term in the sequence. We're also going to find the arithmetic mean and geometric mean, which is finding the missing terms in those sequences. So, patterns are seen in nature. Sequences is nothing but patterns. So like in this flower, it's made up of patterns, sequences, which can be written mathematically. So even in shells, in hurricanes, in what is it called? The the thumbs. And then even in human beings, in the way we are in the womb, in our DNA, in the anemic, okay? There's everything in nature. Most of the nature is about pattern. It's amazing. So a sequence is simply a list of numbers that are related by a rule. That's one thing that is connecting. They must have a rule that is binding them together. And then, so we name sequences by terms. Every number in the sequence is called a term. The first number is A1, which is the first term. Second term is A2. Third term is A3, and so forth. So we have recursive rule. Recursive rule gives us the previous number plus the common difference or common ratio, or in terms of arithmetic and geometric sequence. But in something like the Fibonacci sequence, which is very popular, we see it gives like the two previous terms, and we can use it to find subsequent terms. Pascal triangle is a very common phenomenon that is studied in math. Is full of patterns. The more you add, the more you go on to adding. Like you start with 1, and then you add 1 plus 0 is 1. 1 plus 0, you add both left and right. And it's going to be symmetrical, from the middle down. So then 1 plus 1 is 2. 1 plus 1 is 0. You have 1 on the two ends, and as you notice, and then you keep adding 1 plus 3. 1 plus 2 is 3. 2 plus 1 is 3. And 1 plus 1 is 4. And 3 plus 3 is 6, and so forth. But it's very amazing. So we find the Fibonacci in there as well. So in this recursive, if we are to keep finding the numbers, so if it starts from nothing and then 1, so 0 plus 1 is 1, 1 plus 1 is 2, 2 plus 1 is 3, 3 plus 2 is 4. So this is the previous term, and this is the second previous term. So if we are to find the next 3 terms, we are just going to add these two together, and then we get what's going to be the second term here. So it's going to be 55. And then we have 55. We add 55 and 34. We get 89. And then we add 89 and 55. We get 144. So and so forth. So that would be the next 3 terms there. So with recursive, you're just finding the next immediate term. So that means if you are to find the 50th term, you have to keep doing this until 50. That would be exhausting. So that's why we need explicit formula. With the explicit formula, we can find any term directly. So the golden ratio, which is part of the Fibonacci, the golden ratio, we can see again both in nature and in building architecture. They use that a lot to build fancy, very elegant looking architectures. Okay. In this ratio, it's very amazing. Even in our face, look at the ears, the forehead, the jaws. So everywhere you see it. So arithmetic and geometric sequence now, they are unique and very much studied in secondary math because they are the two basic ones that are very simple, and they have explicit rule that you can easily use to find all the other terms. Okay, but these Fibonacci and these other general terms that you have to figure out, you know, they are there, but I want you to know that they are not the only, arithmetic and geometric are not the only sequences. There are other ones, okay, but we're just going to focus on them in this video. So arithmetic sequence, from the name, it goes by addition. So you add a common difference to get to the next term. So from A1 to A2, we add a common difference, which is, you know, we use the variable d. To go from A2 to A3, we add a common difference. To go from A3 to A4, we add a common difference. To go from A4 to A5, we add a common difference, and so forth. So let's derive the rule for it. So A1 is going to be, we always start with the first one and then plus. Now, but we are not going to add a common difference to the first one because it just started. So we're just going to make it 0. So which is going to be d times 0 is 0. 0 plus A1 is going to be A1. So A1 is A1. Now to find A2, which is the second term, we are going to take A1 and then add the common difference once. So d times 1 is d1, 1d. So we're going to have A1 times d, which is 1d. We don't usually put 1, you know, such as 1d. So A3 is going to be A1 plus common difference times 2. We're going to add it twice. So A1 times 2d. Find A4 is going to be A1 plus common difference 3 times. So this is 3 times in reference to the first one, in reference to the first term. So A1 plus times 3 times the difference. So now let's rewrite this. If we see the pattern here, when we are dealing with A4, we multiply by 3. We multiply the common difference by 3. When we are dealing with A3, we multiply the common difference by 2. But then we want to be able to, so that we want to be able to keep them the same, keep these numbers, make it reflect the same number. So let's see if we can rewrite this A4 as A1 plus common difference. Now, what is 3 in terms of 4? It's going to be 4 minus 1. 4 minus 1 is equal to 3. So that makes it match. And see, we have that number 4 there. So it's going to be A1. Oh, I don't know why I started changing this to multiplication. Sorry, these are all addition. We are adding. Arithmetic sequence is addition, please. Okay, so that's plus, 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 plus. Okay, so in 3 will be 4 minus 1 times common difference. Okay, and you see that that's how we have that n minus. So if we are to do a n mean any term at all, then it's going to be A1 plus common difference times n minus 1, which is A1 plus n minus 1 times common difference. So here comes our formula for arithmetic sequence, plus n minus 1 times common difference. So remember, this is multiplication, okay? But here is the addition to the first term. All right, so we can use this to find any term in the sequence, in the arithmetic sequence. Okay, then the recursive formula, we are given the first term, so we know where to start. And then we are given the previous expression plus the common difference. So in the geometric, we know the number that is being added is your A1, and the number that is multiplying the x value is the common difference. So this is equivalent if you remember function. So this is like f of x equals, but instead of having this as your first term, the only difference that this is the function will have the linear function will have what is it, a0, which is usually the y-intercept, so we call it b. So it's going to be mx plus the b. But here, this is the slope. This slope is the same thing as the common difference. Is the common difference, and this b, the b here, is like the y-intercept, which is how do I call it? Instead of this being a1, it's going to be like a0. So, but in the sequence, we don't use a0, most of the time. So, except in some special, like that's Fibonacci. But it's even that 0 there is recorded as the first term, though. Okay. So write the explicit formula and then use it to find the 6th and the 10th term. So finding the 6th and the 10th term. So now we know the sketch, the skeleton. We just use it. an equals a1 plus n minus 1 times common difference. So if we plug in, okay, we're going to create our using this a1. The general formula will still be n. an equals a1 now is 8. We replace a1 with 8 plus n minus 1 times the common difference is negative 3. Oops. Sorry. Okay, so we just use substitution to replace this. Now, this is the general formula rule for any arithmetic sequence at all. Then this is the explicit formula for this particular sequence that has this that starts with 8 and then have the common difference. Oh my goodness, I don't know what is happening here. Common difference of negative 3. So, all right. Okay, so we're going to use this to find any term we want now. So we are going to find the 6th term. 6th term is going to be a6, which is going to be 8 plus. So wherever we see n, we replace it with 6. But the 6 here, we're not doing anything with it. It's just a symbol. Minus 1 times negative 3. Be careful to use order of operation. So keep this parenthesis, work inside out. 6 equals 8 plus 6 minus 1 is 5. So if you forget to put this parenthesis, then you have the tendency to add 8 plus 5 first, which will be wrong because you still have times this negative 3 here. Okay, 8 to the power 6 equals 8 plus, and then 5 times negative 3. Oops. So that's negative 15, and now we can add 8 to the power 6 equals negative 16. You can say negative 15 plus 8. So that gives us negative 7. So that's the 6th power. I mean the 6th term. And then next we are going to use the same formula again. an equals 8 plus n minus 1 times negative 3. And then we're going to find the 10th term. So a 10th is going to be 8 plus 10 minus 1 times negative 3. So a 10th equals 8 plus 9. 10 minus 1 is 9 times negative 3. So 9 times negative 3 is negative 27. And then we can add 8. So negative 27 plus 8 is negative 19. So we can see that this sequence is decreasing. It started with 8 and then it's getting smaller and smaller to the negative side. Okay, so because the common difference is negative 3, so we're actually subtracting 3 each time. Okay, so that's it. Once you have your formula, you can find any term. Now, arithmetic mean again is finding the average. not the average of just adding them and dividing by how many there are, but it's finding all the missing terms in a sequence like here. So it's called geometric mean. So if we are asked to find the geometric mean, we are asked to find the between -8 and 20. So those are the two terms we know right now in the sequence. -8 is not the first term. Of course, we can see dot dot in front. We don't even know which term they are. So we just know 3 terms are missing in between them. So, and we know the only thing that is connecting arithmetic sequence will be common difference. So no matter what, for us to go from -8 to next term, we're going to add a common difference. To go from that to there, we're going to add another common difference. From here to here, we add another common difference. And from here to 20, we add another common difference. So we are going to add, starting from -8 plus how many common difference? 1, 2, 3, 4. 4 of them. 4D. So this is like 1D plus 1D plus 1D plus 1D equals 4D equals 20. So now we have an equation to solve. So when we start from -8 and then add 4 difference, and we're going to get to 20. So we're going to do the algebra now. Add 8 to both sides. Add 8 to both sides. So 4D equals 28. So if we divide both sides by 4, so 28 divided by 4 is 7. So now that we know what the common difference is, we can now add each of those to find the arithmetic sequence here. So we're going to do now -8 plus 7. So that gives us -1. I wanted to use a different color. So here we have -1, and then -1 plus 7, we get what? 6. And then 6 plus 7, we get what? 13. We have to check that 13 plus 7 is going to give us 20. So that check that this is correct. Okay, so that those are the arithmetic mean, the missing numbers between the terms. So if we are asked to find the next term or the first term, we can also do that. Okay, write the explicit formula for finding the nth term of the arithmetic sequence, given that the 5th term is this and the 8th term is this. Again, this is like we have some numbers missing in between them. So, but if we have the 5th term, since we are given the 5th term, that means when n is 5, the input is 5, the output is going to be -31. We can also use that idea to find what do we need to write the explicit formula. We need the first term. What do we need to find the, so we need to add the common difference and the first term. So we know that this is also 8 terms. So when input is 8, the output is -4. So those are two points on this sequence. So let's find okay, let's keep this one first, and then 5, -31. So move it out of the way from here. All right, so if we have some numbers, we know that this is -31, and this is the 5th term. So we're going to have the 6th and the 7th, and then the 8th is -4. Okay, so we know we are going to add common difference, and common difference, and common difference. So we are going to, if you see the pattern, when we have 2 numbers missing, we add common difference 3 times because we have to add the last one to get the number we have. So we have -31 plus 3 common differences equals -4. And now we do the algebra. So we are solving for D. So we have to move everything on the left side. So we add 31 to both sides. So 3D equals, that's -4 plus 31, which is 27. And now we divide both sides by 3. And we get D equals 9. So now we know what the common difference is. We are going to find the first term. Again, although we know the fifth term, we can go backward and find it, but we can also use the formula and find it right away. So if we have the AN equals the, that's A1 plus, we have that N minus 1D, because this is arithmetic sequence. So we use that explicit formula. And then since we know the N term here, you can pick any of these two. Any of these two we can use. So let's go ahead and use 5. So when this is N, this is AN. Okay, that's that. So AN is -31 equals, A1 is what we are looking for. So N here, N is 5. Minus 1. The common difference we found is 9. And so we're going to simplify it. So -31 equals A1 plus. So we have 5 minus 1 is 4. 4 times 9. 4 times 9 is 36. So -31 equals A1 plus 36. And so we're going to subtract 36 from both sides. A1 equals, okay, so we are doing -31 minus 36. So we have -67. So that's A1. Okay, -67 equals A1. And common difference is 9. So now we can write the explicit formula and then use it to find the 20th term. So I need some space. Okay, I'm just going to erase. Okay, let me see if I can add. Yeah. If I can add, hold on. I might be able to screen, black white screen. Okay, good. All right, so we can have our AN equals A1 plus N minus 1D. Again, that's the skeleton of arithmetic sequence, the skeleton formula. So now we are going to substitute our A1, which we found is -67 plus N minus 1 times our common difference is 9. And we can use this to find the 20th, A20, which is -67 plus 20 minus 1 times 9. So that's going to be -67 plus 20 minus 1 is 19, and 19 times 9. Okay, so we have 19 times 9 is 171. So -67 plus 171. So that's 67. Again, you can do that 171 minus 67. So they mean the same thing. 104, 828. Okay, so that's it. This is a very good problem. Okay, so back where we are here. So we have finished answering this question. But again, so sometimes you can be given any two number in the sequence, you can use it to find your common difference and then write your recursive formula and then find any term. So okay, so another example here. So when you are given the third term and the fourth term, good thing this one, they are together. There's no space in between them, so that should make it easier. So we have some number missing, and then we have the third term, which is 13, and the fourth term, which is 18. So, but the good thing here, we can find the common difference right away. So it's going to be 13 plus a common difference equals 18, right? Because it's just one step there. So we subtract 13 from both sides. So the common difference is 18 minus 13 is 5. So if the common difference is 5, we need the first term. Again, we cannot write there's no way we can find the 50th term without having the explicit formula. So we need to find the first term to write our explicit formula. So if we have the an equals a1 plus n minus 1 times d. So we can use any of these. This is the third term, so this is the fourth term. So when n is 3, n is 13, and when n is 4, n is 18. So any of these, again, this is n, this is an. Okay. So if we take the first one here, substitute an for 13, it's going, and then to find a1, so n is 3 minus 1 times the common difference, which is 5. So 13 equals a1 plus 2 times 5, so which is 10. So this is addition, so we're going to subtract 10 from both sides. So a1 is going to be 3. So now that we know a1 and then we know the common difference, we're going to write our formula. An equals a1 plus n minus 1 times d. So the general formula is going to be an equals a1. a1 is 3 plus n minus 1 times the common difference, which is 5. So this is the explicit formula if we are asked to find it. But now we're going to use it to find the 50th term. So a50 equals 3 plus 50 minus 1 times 5. So a50 equals 3 plus, that's 49 times 5. So 49 times 5 is 245. And then we add, finally, we add 3. We get 248. Okie dokie, I think we pause this here and do geometric in the next video. Okay, it's almost 30 minutes.